the interesting dynamic at the start when Martin told you about affinities, it was like, really kind of a bit abstract, right? I mean, I've done this a lot. I've been at Plexxi like 18 months, and I've seen that with a lot of customers that we've talked to. When they first hear about that abstract concept, it's difficult to apply it to the physical world. So it's good for us to go through, show you about the optics so you get it. To me, it's always, I've seen this a lot. Whenever I see an abstract and I can't apply it to the physical, I don't know what it is. I need to be able to apply those two together. So here, you probably can't see it very well because we have these beautiful little grey lines here that show the affinity topology that we've created. Now, the importance of the affinities is you want to be able to, in your network, apply some treatment policies to your traffic. If you can do that, you can direct the traffic better than you can if we just randomly build a topology for you. So that affinities basically allows you to do it manually if you want to, and dynamically and automatically, feeding in from a bunch of sources. I'm going to show you a bit about our architecture of how Plexxi control works. First of all, I'm just going to build off on what Martin said about affinities, just to show how we describe them. And I'm going to have to clear some of your stuff out of the way, Martin. I was hoping I could leave it up there.
You can flip it around.
I could point to it. Oh, okay.
Wait. I was warned about this. It's big.
Don't break the whiteboard.
Don't break the whiteboard, yes.
Because we may want to flip back to his stuff. And don't go too far, Martin, because I'm sure we're going to need you at some point. Okay. So the way we view affinities is we want to essentially identify some traffic on the network. And you need to give me some high-level parameters to identify that traffic. The concept is once you've given me those high-level parameters about identifying the traffic, you want to give me the treatment perspective you have for that traffic across the network. Now let me draw a little bit of an architecture so it makes sense where we're talking to. Ring-wise, it's a quick version of the ring. Imagine a small little Plexxi ring. There is a Plexxi control here somewhere. All of the switches are talking to it via a broker. And that's an interesting thing. Building a new network product. I've been involved in a lot of networking products over my time, and a lot of vendors. Building a new network product today gives you the opportunity to do things 21st century wise from a management orchestration perspective. And I'm talking about, here we essentially have ActiveMQ broker that all the switches talk to push all these messages in. Martin talked about pushing MAC addresses up to it. That's how they get there. So they have a path to it. This is kind of our internal interface, but it's worthy of talking about it from this perspective.
I hate to get all stupid low layer again. What is that connection back to the broker? Is it part of the fiber path, or is it a standard Ethernet path?
You just got to make sure there's IP connectivity to it.
But you've got to assume that there's IP connectivity from at least several of the nodes.
Everybody's
in the
going
event
to
of
have.
failure.
There's a management port in every node, and that needs to be on the management.
So you either build an external management or you let it go across the network.
You can do in-band or out-of-band.
Yes. Exactly. So it needs this connection to be able to push up information to the control. This is Plexxi control core, as we call it. So the little broker JMS connection gets the data up there. So that's how it loads.
And the broker is a separate box, or just a component on the...
The broker can be distributed. ActiveMQ, horizontally distributed messaging layer. So how do you get masses of messages come up? You use modern technology for it, which is what we built it to.
Okay.
It's all software, so it would be just a bunch of units.
Yep.
We had one of these interesting questions early on from development team. Do we support SNMP in this box? It's my favorite question. What do you think the answer was?
The right answer for now is yes, but there needs to be something better in the future.
Yeah. So that's exactly what we've done, luckily. Glad you said that. So these things do push out SNMP.
Think like a product manager.
There's SNMP here. But there's a much better way than this, which I'm going to talk about when we go through the architecture. Before I go too far in the architecture, you just got to get a feel for it. I'm defining affinities now. The point of defining the affinities is here we have a thing called a fitting engine. Great name. This builds the topology for the network. This is a PhD mathematical science algorithmic engine that takes in essentially a traffic profile of the network. So we're monitoring the traffic. We know how much traffic is going between this guy and this guy. And we can build a topology based on the amount of traffic we see without knowing anything about that traffic. Okay? So it's essentially that.
That sounds like math that's a lot fancier than Dave Myers math, whatever his name is. Right? That's like super fancy math. PhD mathematics in a little box with an F on it.
We got more Greek letters.
Yeah, the little F does the computation. So
That's awesome.
the thing is, as a user of this, you don't have to understand the maths, which is very important. You're looking at it from the affinities perspective. But it's important to realize that if you have not defined any of these affinities, we're still building a traffic profile based on the topology. The fitting engine builds that. The way you typically deploy this, first time you deploy it, you put the switches out, you've got it all communicating, all the hosts on it communicating. You will do a first time fit, as we say. You'll push the topology to it. Let's say it's within an hour of you installing this network. We don't have much of a history on the traffic at that point. We have an hour's worth of history. The next day, we've got a day's worth. Maybe we've got a better idea of the traffic profiles. The next day, on day 2, I'll run this fit again, and I'll recompute the topology based on the traffic profile that I now see. The important thing I'm saying this is, the affinity abstract thing that we were talking at the start, I haven't defined anything to enable this to work. And let me give you a couple of examples of why this is important. Is that if I am seeing, let me draw another note here because it gets better with that example. If I am seeing a lot of traffic between these guys, let's say they're getting to the point of exceeding the capacity of these direct links. Okay? When I compute that topology, I know here, this controller knows that actually there's very little traffic between here and here. So when it recomputes the topology, it's going to push some of the traffic flows this direction, because there's very little capacity being used. Spatial reuse, basically.
Are you exporting, are you taking flow data? Is that where you're getting your analytics?
We look at every packet. We are not necessarily diving into the flows to be able to build that traffic matrix. It's more of a summary of the traffic to build that.
Okay, so packets per second stuff. So
Interface.
okay.
And then
There's no application awareness from that
Right.
unless it's been classified somewhere.
This is unaware of any affinities or any application.
At this point, I haven't defined any affinity. I've told nothing. It's classic rear view mirror monitoring. I'm looking at what happened last week to build my topology. How can you know what's going to happen tomorrow if you're looking at last week's traffic? You can't. There's got to be some input from someone somewhere to give us a better topology. That's where affinities become interesting, because now you can tell us, and when I mean you don't have to manually do this, you can tell us from your orchestration automation systems that tomorrow at 12, I've got a big backup. You might want to get some bandwidth for me. There is a long list of interesting dynamics we can think of to how you can build better topology. I'm building on a new tenant that needs to be isolated.
So something as simple as I've hit a threshold at 80%, if I go any higher, I'm gonna start degrading and everything's gonna start backing off, spin up another lambda, right?
You could do that. Absolutely.
I would think that'd be pretty attractive.
Pretty like yeah. I mean, the first one you came up with, I think it's a good use case for where you may want to actually recalculate the topology. Now, this first topology calculation did everything. We would expect maybe day 2 or day 3, you don't necessarily want to change everything. You're tweaking it a little bit. So over time, you're going to adjust. See, oh, there's no one's using this. Let me push more flows this way.
I think the cooler use case is what I said earlier, which is we quit re-architecting the network, whether it's virtually or through lambdas or physically through re-architecture. Architecture, that's a word. Instead, use the data that we're grabbing here and just move the host.
Yes.
Move the host close.
The other way to think about it is
within.
that,
That makes more sense to me.
Yeah.
If it's the right use case. In heavy multi-tenant environments, it won't work. In standard data centers, that makes all the sense in the world.
Yeah.
Yeah,
So one of the very cool use cases is the Plexxi control can actually start to advise where's the best place to put my next set of, orchestrate my thing, and it can start to
Amazing.
communicate with the orchestration layer, right?
Well, there's another dynamic to that actually, which my understanding of where you decide to move a VM is generally based on the physical resources of the host, the memory, CPU availability. That's one of the criteria where you're going to put it. Maybe the availability is here at this point. The engine that decides to move a virtual machine here obviously doesn't know anything about the network. The thing that we can do, once they've decided to move there, we can now modify the topology to match the fact you moved it there. So instead of you worrying about where it's going, we'll fix the network to actually match it. That's a different paradigm.
But you can flip that.
It's
And
just
then-
the way
that's
it
another
both ways,
difference.
but-
Because we know this exactly, we can actually tell your orchestration is, well, we prefer you actually put it behind that switch somewhere.
Yeah, the way we do workload placement today is, CPU memory availability, right? That's kind of the models. But we could actually add the network dimensions.
But that's because we don't have a lot of control over
That's
the
right.
network.
We don't have the data, right? We don't have.
All right, so let me talk affinities a little bit so we get there. So the concept of affinities is a way to define it. We want you to be able to define something abstract and then apply it to the visual. So we've created, and I'm showing it on the screen, essentially a concept of creating identifiers to be able to identify the traffic on the wire when we see it on our switches. The identifier can be a range of things. It can be as concrete as a MAC address, VLAN pair, IP address, node, VLAN, VXLAN, DSCP mark, essentially anything that we can do to identify the traffic. We take these identifiers, what I think of in terms of groups of identifiers, group them into something we call an affinity group. That's what you're seeing on the screen there. The orange blobs are what we call affinity groups. And I've created this affinity group with these identifiers. Maybe in this case I've identified this mode, but by node names: Simon, Bob, and Derek, whose name I can't spell now. So they're identified. I haven't told anything about it at this point. I've just identified that is a group that's interesting to me. For our affinities, you now need to give me some treatment policies across the network, something interesting to do with it. So we create a thing we call a link, which can be bidirectional, can be unidirectional. You may want treatment in one direction different to the other direction. So it's up to you. Let's say I've created, in this case, a unidirectional link. Where's that going? It's going to nowhere right now. It's going to go somewhere soon. I've got another couple of identifiers that I've identified another couple of machines, call them A and B for want of another, in another affinity group. Now here is where the really important thing was. Now I want to define my treatment for this traffic. So on here, we have because of the nature of the Plexxi ring, we have some really interesting things we can do with the way we deploy the topologies across the networks. I'll talk about two of the main attributes that are interesting, the easiest ones to get. First one is isolation. So my policy for this is isolate. And guess what that does? When we do the compute of the topology, the first thing we're going to do is make sure Simon, Bob, and Derek have an isolated link to A and B. And that isolated means no other traffic will traverse that particular port on the Broadcom to that particular port. So we've got a lot of residual traffic flowing around. We make sure none of that traffic goes across that physical link. And that's basically a layer one separation of the traffic, just based on you defining that policy. Now here's the fun part. So let's say A and B is here. Let's say B moves. We can basically make sure the computation can say, oh, actually, I really need to use that link for B now, because he's over there. As a user, and this is really interesting as well, as a user, I don't need to care where Simon, Bob, and Derek are, or A and B is. I just define the policy. Plexxi control determines where they are. Now, I'm not a big fan of, I expect most of you, when you're on networks, you don't memorize MAC addresses and things like that. We build topologies based on forwarding packets in MAC addresses. So how can you tell me about Simon, Bob, and Derek? I need to know their MAC address, essentially. Well, Plexxi control needs to know what's the MAC address of these things. And this is where our architecture really comes into play, is the orchestration layer able to learn, essentially, user terms for the nodes on their networks, in the terms that they have, as in, I know host names, VM names, VM host names, IP addresses, things like that. But for Plexxi control to work, we need to get that data from somewhere. So let me drop that out and I will talk more on. Does that make sense on affinity groups? I mean, they're another good affinity group. Actually, I was going to say the second one. We can do hop count affinity. Hop count means give me the shortest path across this. Now it's very valid. Assuming you've got a data center with a lot of traffic, I may have a ton of traffic going across here. So it's very valid to use this path for additional traffic to get there. But I may have a latency sensitive application. If you tell me in terms of affinity that these nodes are latency sensitive, I will make sure their traffic goes on this shortest path. And all this stuff that's not latency sensitive, I'll send them around this one. Got it.
I got a question, maybe just drop some bits along there. You said when B moves, control notices that the MAC address is now in a different place.
Yeah.
How does the topology get adjusted?
Well, there's a few things that we do. First of all, actually it comes from how did we know what B was in the first place? Is the first thing I need to talk about. So in terms of architecture, this is control. Control has interfaces to third-party boxes. So that's one of my interfaces. Third party. One of these third parties just so happens to be VMware, of course. So we do a connection to VMware, and we ask VMware, please tell me about all your VMs. So it gives me vhost information, the VM containers within the vhost, the MAC addresses, IP addresses, vSwitch information, port group, VLANs, everything we can get from this particular one, maybe a vCenter.
So it's a vMotion trigger rather than a MAC on a different switch.
So
my question is, what type of activity? Because if I have vMotion going on all over the place, am I constantly flushing new topologies?
Do you have a lot of vMotions going on your topology?
Actually, I had a customer that was doing what I would call triangular DRS stupidity.
Yeah.
Where they put them all in the same
interesting.
priority group, and so the whole class body moved to the next hypervisor every 20 seconds, and they finally
Every 20
noticed it,
seconds?
and they noticed these 40 VMs moving because they had only a 10% degradation in performance.
What was the restriction that had the VMs moving that often? Like, what,
It was the granularity.
was there like a gremlin running through the data center smashing servers left and right?
Was that
No, it was the
hyperbole?
whole class body would move, the CPU would spin up, VMware DRS would notice it and decide to move the whole priority group.
But no, there is a use case for this
Shoot yourself
actually.
in the foot.
And the use case is actually VDI with DRS. So you start your day with nothing but server load,
Giant
and as your
circle
client
jerk.
starts spinning up, DRS starts allocating resources. And this is the classic model around DRS. You start at 8 or 6 a.m. with nothing, you end at 5 with a lot, and then it pairs itself down by 8 again.
Yeah.
So there is a use case for
So,
this.
well, I'll tell you what we do in that case. So, we built the topology. Simon's talking to A and B over here. B moves it over here. The first thing that happens is, because we've built this topology for traffic that we have defined outside of this connection, it will actually just will use one of those topologies right away. So B will immediately just continue to talk to S. It doesn't need any changes to topology. Everyone's got connections to everyone. So what would happen is that B would go on. When I was talking initially about what if we don't know any affinities, we build that topology, we balance the traffic on that topology, B would just go on one of those paths. Now, if you need that preferential treatment for B though, like you need that hop count, then we need a bit of a tweak from the fitting engine to tell us to change something. What fitting engine does in terms of, so you can see it on the switch perspective, the fitting engine is essentially configuring each of these switches. So this is probably number one important use case for Plexxi environment. You don't go down to these switches and start configuring TCAM entries. Plexxi control does that for you. So when it refits this, because it's got to do that, it's just going to change that TCAM entry. But it's got to do that. Even if it doesn't do that, it doesn't matter. It's still going to, the data's still going to get there.
So,
It's not gonna keep
Today is manual, right? It's a manual action. It's not like, we notice something moves and automatically go and push down the topologies. Today, it's an operator triggered event.
But it
So
could
VMware
be
is not
automated.
VMware is not automatically alerting it and triggering a fit.
It doesn't trigger, yeah, you can set it up to do that, you can set it up to detect a trigger, run a script and run a fit, or you could have a scheduled fit, and We think about it like defragging your hard drive. Like, you know, how often do you want to do it, right? You want to do it every hour, do it every hour, right? Just set a script to kind of run the fit operation. If you know that's your dynamic, you can do that.
Yeah, if you're immediately the traffic continues to go. If you desperately need this to be recalculated in the terms of the fit, then we can plug into other things. We have a lot, the third party areas, it's like any vendor when you're dealing with third parties, there's 1,000 third parties we need to work with, and we have done it with about 6 or 7 right now where we've actually built third party connectors to harvest information. So probably one of the most interesting ones we've done, and if you Google Plexxi, you'll see a press announcement from a company called Boundary that does performance monitoring across environments. They've got basically a cloud system where you can deploy their meters in your environment. They've got a cloud system where they push all the data up, and you can then look at your data traffic profiles in terms of applications. We did a plugin with them where we pulled all of that conversational performance information and we turned it into affinities. So from a customer perspective, you're using Boundary, you know all about your application workflows, it's there in Plexxi automatically.
So I need to make sure I'm understanding. So we're taking the policy in the controller's proactively instantiating in the flow tables, right? So
Mac tables, TCAM tables, whatever it needs to do.
Sure, so
Yeah.
single table, multiple tables, Cartesian, some of those problems, is it all a single table? And then how many parameters am I able to deal with? So, and then action, is that gonna be a lambda or a physical interface, right?
It depends where it needs to, where the data, first of all, from the Lambda perspective, if it needs to be on a Lambda, it'll put it on a Lambda. If it's out of an access port, then it directs the traffic the way it is. Table stuff, talk to Martin. He's at the back there, hiding.
Okay.
There's multiple tables, there's lots of
Yeah,
tables.
no, I'm just-
As a user, I'm the software guy as a user. I don't need to worry about tables after that in switch guys.
Yeah, well, and I guess just broader for an operator, what can they take actions on, right? So we look up, L2, L3, L4, are we doing any rewriting in there? So I mean, some of the same problems that, we're kind of talking about.
So there's really, I mean, ultimately, the only limit that exists is what can the chipset do for us, right? And so all the things that you think that you can currently do with your chipsets, not saying that we have every single one of them implemented today, right? But those are all possibilities of us treating traffic and affinities and what we can use as classifiers. So we're essentially, on the controller side, there's no limit because it's pure software.
Sure.
It's truly on the hardware side is how far in a packet can we look and what kind of actions can we then take based on that.
So you got Trident Plus, so you're what?
Trident Plus today, Trident Plus
1,500 rules, is that where you're at?
It's about 2,000. But remember, right, not every single one of these ends up in a TCAM entry, right? I mean, those topologies, those forwarding topologies, right, the basic forwarding topologies, none of them end up in TCAM entries. Those are purely us deciding how we populate MAC and IP forwarding tables.
Are we gonna get to see a demo of Mailin? That's-
Oh yeah, I'm going through the demo,
Awesome.
but it's
No, I don't wanna write, I just wanna make sure it sounds cool.
Well, what I'm showing here, and I basically created an affinity policy. I've got some auth service, I've got storage box, and I've created an isolation policy between them. The key thing is how I basically described how do I know what these are. We learned it through one of the third parties, be it VMware, Boundary, or any other variety. We are, as a product, API-wise, we're very much REST API-based with event monitoring pieces, but we do some of the SNMP stuff if you want to do that as well. You can, I'm slowly drawing up all the interfaces here. It's important to have a lot of interfaces for a product like this, because we need to both be able to integrate very seamlessly with the orchestration systems that are out there, and I'm using that term orchestration system to mean about 150 different types of management system. It's the best word I can think of right now. The manager of manager type systems that we need to talk to. And also you can basically SSH to a switch if you want to. My goal specific in the world is to avoid you ever needing to do this SSH to a switch. Because I can give you want to manage this network, you basically manage it from control. And you need to do it automatically so we can interface with those orchestration systems, but also from an enterprise perspective, customers need to be able to use it at a high level without worrying about things like that. So we have a REST interface. So when this first comes online, the switches talk through this broker to the core, and there is, oh, surprise, surprise, there is a little database here. I knew there was another picture. And it builds the topology model within the database. Topology model in terms of everything about the switches, the ports, what is attached to those ports, MAC addresses on ports, the status of a link, etc., is pushed up to Plexxi control. So as a user, when you want to look at it, you basically can use one of our control interfaces and essentially orchestrate your network switches without going to each individual switch. Now, if you've got a real low-level troubleshooting problem, you can still go directly to them. And there's an interface here as well. There's another one. So you see there's a lot of REST interface here. So this GUI, what I'm showing here, this is every action that I do on this GUI essentially interfaces directly. Yep, that's what I'm doing. Thank you. This interfaces directly with the through the REST interface to the database. The importance of doing that is when you've got interface, when you have multiple interfaces to talk to a system, it becomes complicated. Really, there's only one underlying. And so from an automated perspective, if you're a customer that's a REST automated-based customer, you can build it all yourself. And allows us to build a lot of high-level stuff. Now, the problem with the demo is that the laptop's down here, and I basically have to sit on the ground to move things around. So that's my excuse for not doing too much so far. So you can see in this view, I'm showing our affinity group view. So as a user, you can stick to this if you want. Just build your topology. You can basically create a role, a user role that just builds affinities. They don't have to worry about the physical network topologies to do that. But Plexxi Control does need to know about the physical topologies. And if it wants to build affinities, it needs to know what things are and where they are. So we have another view here, basically our network view. So what I'm showing you here is, this is interesting because this is a simulation, obviously. I don't really have a Plexxi switch anywhere here. So I'm basically simulating a Plexxi environment. And I've simulated harvesting information from VMware. I've built a bunch of vhosts constructs. You see, these are like a little stack of vhosts. Actually, that's telling me it's got 10 vhosts, 28 VMs.
Simon, this is the actual tool though that you would use to manage the product, right?
Right.
Right, so the simulation is on the back end. The tool is talking to a simulation.
The Plexxi Control in this case is actually running on a VM on my Mac. Plexxi Control thinks it's talking to switches.
So did you draw that diagram
We've tricked
yourself?
it. It's not really a switch there, but it thinks it is, which is a great environment to
We
test
actually
it.
provide a simulator to customers, so you can actually simulate your entire network without ever touching hardware. You can do all these things.
So so here I can basically build a topology of your network if you want. As long as you give me the right input to this. See what I've got here? I've got a host. I've got a Cisco switch here. I've got hosts off the Cisco switch. I've got a bunch of storage devices.
But did you manually draw that?
This was automatically drawn. So once we harvested all. Actually, there's an interesting dynamic of the way this works. So we harvested from VMware, told us all about all the VMs and vhosts and everything. Okay. At that point that I've harvested, I don't know where those things are. Okay. VMware doesn't tell me which port on Plexxi it's on. It just tells me, essentially, here's the network credentials for it. So what happens in the network is say this iSCSI 0 box is here. When he first starts talking on the network, we see the MAC attachment for him. That MAC attachment ultimately is pushed up to Plexxi Control. Plexxi Control then does a hash match with that MAC address and the one I learned through the manager for that iSCSI box, and automatically builds this. This is like a network link in our domain model, so it automatically populates it. So what you see happening, if you see these MAC attachments occurring dynamically, you actually see the network topology updating in real time and things appearing and jumping in the topology. Now, this is actually drawn automatically, so there's a toolkit we use, a Java Infosys toolkit, which is basically a dynamic topology building tool. So that builds it first time, and then I can do this nice operation that makes everybody. I can move things around, so I don't quite like that topology it built, so I can move these guys up here and pull this guy over here like that, and then I can save the layout. First version we didn't save the layout, so every time I did something and added something, it redraw the thing again for me. I had a lot of fun with that early on. So this just, the interesting thing about this is just telling me only the things I harvested from those third parties. There may be other traffic on the network. If you haven't told me about it, again, it doesn't matter, it still continues to pass. This is the important stuff. And the reason I say that, and this is really important, if you have to harvest and think about every system and you've got a big network, it's too much. Focus on the ones that are important. The stuff that you don't harvest, maybe it's not so important. We'll still push that data around the topology, but we can do the preferential treatment for the stuff that you do harvest. And then it makes it, the abstract makes it maintainable.
You told us there's a fully automated version of this, so you can just kind of set it and get it, and it'll figure out flows all on its own and dynamically route those and everything all on its own. There's a fully automated version of this.
Yeah, I mean, this is fully automated version.
But I mean, it'll actually, it'll detect affinities. It'll dynamically choose affinities between.
Yeah, let me show you what happens in terms of affinities. So I'm back to the affinity view. At some point, I basically, so I built a bunch of affinities. I built this one, which happens to have an isolation sensitive policy. Isolation sensitive means we're not going to put any traffic on that link unless there aren't any other links left. Isolation, I could very easily isolate my entire network and have nothing left if I just said isolate every single one into a group. So that's a sensitive thing, means don't be strict. Now, conceptually, we could do strict and then make it strict. Isolate means isolate. Does that make sense? So what I did is like, okay, I told it to do isolate. I haven't told it about anything to do with these guys. I know there's a host there, but it's not that important to me yet. Maybe it is tomorrow. Go ahead, Dan.
So Simon, let's say you did want this whole process of affinities being automatically.
I'm going to get there, trust me. I'm quickly zooming there. Yes, you can automate it. And I've got an automation demo, so it's going to be, or I'll show you the power of the automation. But what I did actually, so when I wanted to make this so on the topology, I basically run this operation. It's a fit operation. So it basically asks me, what kind of operation do I want to do? Do I want it a full or partial? Do I want to just process it? And this is really important, because let's say I built a bunch of affinities, and I want to check out what it'll look like on my network. I can just run the perform fit processing only, and it'll basically compute the next topology, and then present it to me. I haven't done anything to the switches yet. It says this is what I'm going to do if you push it.
So
if you like it, you push it.
So this is what is really, I think, insanely cool about this, right? An affinity basically says this stuff wants to talk to this other stuff in some way. And if you build like 40 of those infinities, right, describing endpoints in your network that have to talk to each other, the fit will reconcile, based on what's available in your network, the best possible way to meet the requirements of all of those traffic descriptions for you.
And then configure all the switches for you.
And then configure, yes, and then configure the switches for you.
And all you've done is say, process it. So I did that earlier. This is what I prepared earlier. So I ran that operation, and this is what it told me it was going to do. So a bit complicated, but essentially let's look at it in terms of the flows that I've got. So I've said from my iSCSI box, so from the storage, show me the paths it's going to get to these two guys. So it's told me it's actually computed different paths for these. I guess auth machine 78, I think that says, is on, let's see if it gives me the answer, 76 actually. I can't even read that, I'm standing right next to it. Auth machine 7, iSCSI to auth machine 78 takes this path. What does that mean? It's some mnemonic there that means nothing to me. Actually, I can show it graphically, so why don't I take a look at it? Aha, so Plexxi ring view. So it's drawn me the topology saying actually to get from iSCSI to 76, it goes from here to here. Right. So I know what's interesting now is let's say you want to know how any device talks to any device. In this database topology model we've built, you can essentially ask it, tell me how device A talks to device C. And you can do it in terms of MAC address. So let's say all you know is the MAC address. You can say, tell me how this MAC communicates to that MAC. or you can do it at a high level. If you've got a host net, tell me where this host is. Tell me how this host talks to that host, etc., etc. And I can see from a topology level, this shows me the skip perspective. Of course, I showed that traffic going direct. Actually, it went via this switch passively. The one that's grayed out. Go ahead.
I'm having a bootstrap problem. Maybe I'm just being obtuse, but I have a whole set of questions here on bootstrapping this whole process that I have a chicken and egg problem in my head.
Yeah.
Most network admins that I know, I ask them, who's talking to who? And they go,
I don't know. I
what do you
agree.
mean?
Isn't it wrong though?
You want me to do what?
Put things
They
in
don't
here and
even
they come
know
out
which
there.
servers
Yeah.
talk to which servers. They can't tell you any of this stuff. So that's one of my questions.
So the
Okay, so hang on,
Okay.
let me kind of outline.
If
what my
you ask too many
confusion
questions,
is here.
I'll lose them all.
Because you may have one sentence that covers everything.
All right.
All right, so you also have this fit engine that runs. What happens at t equals 0? You have no data.
So I'll
Okay,
tell you what
so
happens.
that's another one is what
That's a
happens
different
at t
answer,
equals
but I-
0 because
What was the first question?
anything could talk to anything. Okay, but you have no data, so how do you know what
We build a balanced topology.
links? Okay.
With no data, we build balanced topology, which
Okay.
means all these links that Martin showed you about, they're all available for everyone and the traffic is balanced.
Okay, all right, so.
So you've got, if you look at the capacity that's there,
Oh, I understand.
tremendous
I
amount of
understand.
capacity.
Okay, I got it.
But when we learn over time the traffic matrix, then
All right, so I'm the pointy-haired boss. Oh, everything can be protected from everything,
Oh,
isolated. Everything should be protected from everything. Configure it that way. Okay, and Dilbert's sitting over there going, oh, that doesn't work. And you kind of hinted to that just a minute ago. So what happens when pointy-haired boss says, everything has to talk to everything, and all has to be isolated?
Well-
Work for customers that have that.
we do need to train the pointy-head boss a little bit. I mean, I understand he may say, I absolutely want this. His rings can get
He's
pretty,
a pointy-headed boss.
his rings can get pretty big at that point. If every single flow has to be on their own isolated link. I mean, it's a big Plexxi ring.
Okay,
I
so-
don't mind necessarily, but we do have to do a lot of, with this whole concept, we have to do a lot of customer training. A lot of this is new, so people have not worked in this world before.
Okay,
So we're giving them
maybe-
tools which are fun.
Okay, so you're kind of filling in a little bit of the stuff here.
So Terry,
And
can I address the first question that you had? Because I think that actually gets into something that's pretty interesting.
Well, I wanted to
I
kind of
covered that on,
Let him ask his question.
cover
We'll
what
stop
my
interrupting you
areas
for
of
a few
confusion
minutes.
are.
Right, sorry.
If you drill down on one, we don't have time to get to all of them. And like I said, you may have, oh, here's your confusion. Okay, so you talked about 40 affinities. I may not have anywhere close to that small a number. How about 1 million affinities? I'm in a big damn data center. I may have 1 million flows easily. I may have 1 million flows per second. Tell me about scale at those kinds of numbers. And, okay, so the fit thing says, I'm gonna go out and harvest this data from other sources. But it's t equals 0. How do I know how to
Balanced
reach
default
those other
volume.
sources? Okay, so that's kind of all the questions that I have bottled up here.
the guys at the back don't want to answer, I think.
We just want to make sure he has a chance to ask his questions before we talk over.
Well, you keep telling me I've got less than a minute left, so. Yeah, if
That's pretty
it's
much
wrong.
it. So you answered one question, which is you just kind of lay down a default set of connectivity at t equals 0, and then you start looking at the traffic. So how frequently does the fit run at that point, or should I run the fit at that point?
It's totally up to you. You can automate it so it runs once a day, maybe once a week, maybe once an hour. I mean, we're allowed to be basically.
So the switches operate as a standard network, so they'll start, doing switching and routing like they would do, right? The act of doing the fit is say, well, I could do better, right? And I may want to do better. So if I've collected some data, maybe I should look at that and do a fit, right? So it's really up to you if you want to say, okay, maybe I could balance this traffic better based on the data patterns that I see, right? None of that requires any of the harvested information.
Okay.
So the point about harvesting, and Simon mentioned that, is
Make it more rich.
first, an affinity is not a flow, right? An affinity is a relationship, right? So you may have 1 million flows, but that doesn't mean you have a million affinities, right? What the affinity is a relationship that I care about. It might be to, from an app server to a database server, happens to be, and if you think about kind of what's the normal workflow when you set up a network? You design your network, you kind of talk to your app guys, get a general idea of what you need to do.
They don't know, I can tell you that.
They may say, look, we're running high performance application, whatever. You get some general sense, right? You build a network, and then what do? You wait for the phone to ring, right? You say, okay, my application's not working anymore, it must be the network, right? And then what are your tools at that point? DOM, traceroute, right? So what we're saying, well, you have a rich tool set here. You can say, okay, let me understand what your application is. Let me point me to a repository of information. Maybe it's vCenter, maybe it's libvirt, maybe it's something else. But help me understand the application. Help me model it. And once I model it, then I can say, well, what are the constraints you have for this application? Is it delay sensitive? Does it need a lot of bandwidth? And then I can do that, right? I don't have to, and so you can think about this as a standard network model, but except I have now a set of advanced tools to go understand what applications need. So it doesn't have to be thought about in the, I got to learn everything to do anything.
Right, but we have an integration existing today, and this is just one of them, and it was done in Python actually. So this is within reach with other tools, not just Boundary. But with Boundary now, you can actually document those relationships, and it'll self-document.
Yeah.
And that is enormously powerful. Being able to self-document what's happening on not just the topology, but what is actually happening on the network.
Boundary puts an agent in your servers, so your Windows and your Linux, and then it tracks every single flow, creates micro records which are then exported into a cloud, munge them through a big data app, and they can actually tell you, create a complete flow map in the application from the NIC driver.
It sounds like another way to do what Augment does from packets.
But it does it so from my point of view, I'm building a cloud, and my VMs could be anywhere on a VM, on a hypervisor, anywhere, any point. So I need that ongoing. I could wish for that sort of analysis so that I could then retune my network. And then by closing the feedback loop. So we talked at Brocade about open loop feedback systems. That is, there is no feedback. You make a change and there's no feedback to tell you. Whereas when we, in OSPF, we make a change, we see the feedback in that we see the update to the routing table when we change the OSPF routing protocol, close feedback loops. Systems like Boundary close the feedback loop for Plexxi, so that they can then say, well, this is the data paths across the network. Now we can reconverge around those data paths, derive the affinity table, and forward data according, reconfigure the bandwidth dynamically. And change it. So hang on, I've got, for example, somebody's just deployed a Hadoop cluster and they've taken 20 nodes out of my VMs, and I need to suddenly find a whole bunch of bandwidth to support that, and I need to make a change. Well, that's something that this type of feedback loop can create.
I'd like to see that, because I've been wondering about somewhat the same problem, because we've both seen the same situation. I've watched one organization take this $500,000 tool and spend a whole day mapping one application that consisted of 20 servers.
Yeah.
And after you do that for your top 10 applications, they give up because it's too labor intense.
Yeah.
You know what? It's actually, it's actually worse than that. When I was in financial for a long time, and what security people don't like to hear is, I don't know what these servers are doing.
Yeah.
They don't like to hear that, right? They're like, well, something got hacked. Well, what are the data flows? Why would I care about the data? What? I don't know. Network guys don't know, because they build for universal reachability. They turn up a port, and if you put packets in that port, it's going to get to the other side of the network. They don't care what's coming out of the server. The app guys don't care what their tools do. The libraries they load, the frameworks they use, the OSs they build on, they have no clue what those things are doing on the network. And security people don't like that, right? And so, not just for resources, but having a tool like this that will tell you what is happening in the network so you can self-document those flows is enormously powerful.
Yeah, I wanted to build on Terry's scaling question a little bit. What are you seeing customers do in really large environments? Are they building gigantic single rings, or are they building multiple smaller rings and then federating them somehow?
Right now we're seeing multiple small rings. I don't know about federating, but they're multiple small rings.
So then how do they interconnect the two? And is there intelligence? Do they know about each other? Is the controller know about multiple rings? Is there anything that happens there?
So you can in a way you can look at them as you can stack them. and so they do know about each other. So you can create N connections between two rings. They'll realize that they're talking to another Plexxi ring, and they'll smartly distribute traffic across all the interconnects between them. So you could take a ring, take another ring next to you. You can like, okay, I'm going to use 810 GeGs to connect these. And you'll realize that there's another Plexxi ring on the other side, and we'll use those 810 GeGs and distribute the traffic based on destination MAC address in this case. But we'll distribute the traffic evenly across those 8.
And in that case, the affinity kind of exists within each ring, and then we distribute traffic evenly. What we're talking about in the roadmap, when we optically connect the things, we can have affinities stretch across n number of rings, right? And you can create that model. You don't have to care about what ring systems.
And you can keep stacking rings, stack them on top of each other. Or right, I mean, or you can take sort of like like, I'm going to take a ring, I'm going to take a traditional big honking router, stick it in the middle, like have a bunch of uplinks from one ring to a big honking router and down to another ring, right? That's totally legitimate as well.
So two quick things. So the reason we talk about Boundary a lot, we did a partnership with them. One of the first things we ran into was, your question, right? I don't have telemetry data. I haven't instrumented my network, right? And the reason we architect and control this way is you don't actually have to have a lot of data. You can just say, I don't know what it needs. I just know that it's bandwidth sensitive, or it's hop count sensitive, things like that. And that's enough for us. It's kind of fuzzy logic enough for us to go at least say, hey, we know that this has some certain requirements, and we'll use that. Now, if you want to actually, instrument your network, right? You have a couple of choices. You can go buy probes and stick them on, all your links or in certain places. The nice thing we liked about Boundary is that it's a simple download. You instrument, it basically collects pumps up IPFix data up to a SaaS offering. And, literally within minutes, you're starting to see a data model starting being built. So, and you don't have to instrument your entire network. You might just say, hey, I just want to see what this application is doing. I download meters to these 10 servers. I go point my browser at a web page, and I start to see. I get a better idea of what that application might be, and maybe I'll see that, hey, there's a lot of we actually did this for the Boundary application itself, which is kind of like it's basically a web app with some big data capabilities. So there's a component that does there's certain pieces that have lots of data correlated between them. So we saw that and we said, okay, now we can build that. We take that information and use that to build Affinity. So the other sorry.
So what do you typically see? We're talking about the scaling here with number of affinities. What do you typically see in a real deployment?
Well, they start off with low number of affinities, and I think they've not started affinitizing everything because of the problem you say. They just don't have a good feel for their profiles of traffic.
The fit engine automatically determines affinities based on traffic loads.
It's only what we feed into it through that affinity group.
So affinities are not automatically generated, right? So
okay.
affinities are imposed on top of topologies, but the topologies that we calculate are independent, right? Affinities is something that comes from the outside. It's you or some third party that needs to feed us what they are. But for regular forwarding between your million flows, you don't need a single affinity. Just go. It's forwarding. All that control is provided is switches with, here's the topology of how to forward that. Not a single affinity. You don't need a single affinity for your network to forward across all those links that are available.
Okay, so that's different than what I was hearing earlier, because I heard there was almost like a fully automated tiering mode, which is exciting to me. So what I might have missed is the fact that you can make an affinity that is more of a policy. Is that true?
Yeah.
And it will effectively look for those criteria and then apply. So if you see two people talking, within X distance, you do this with them. So an affinity is not necessarily just a one-to-one relationship. It can be a policy group.
Correct.
But it's configured on the switches, so the switches know about it when they see that traffic.
The thing to remember, right? So Plexxi control is a programmable entity.
Yep.
Right? And so you can have you program nothing, in which case it will talk to the switches, determine topologies, and will find the best way to balance the traffic across those links. Or you can feed it smart information. You can feed it smart information from vCenter. You can write a script that interacts with Boundary, grabs stuff, and automatically provisions affinities and then applies those, right? So that there is a mechanism to create that feedback.
There's something I've taken from this whole week so far, and actually from the kind of Esteem thing in general. It's the concept that I'm calling fully automated network tiering. We have fully automated storage tiering right now. And when you build a data center day one, it really doesn't matter because you just have this really big, fast architecture. But then the next gen comes, And it gives you the opportunity to then start creating tiers of network and tiers of service pools that aren't just storage but also network as well. So you get a lot less rip and replace. So if you can create at least policies that can start doing that, even if it's not native, you can create the policy groups that create affinities, that's powerful. It's not powerful today, it's powerful in 5 to 8 years, so the rip and replace doesn't happen.
So you absolutely can do that.
Cool.
The only thing I had left, I realize time is up. We have an interactive shell. I'm going to talk about this for about 30 seconds. So I ran a couple of commands. Basically, there's a Python interface to that database. So you can get right down and dirty into the details of that topology model. When you can get down and dirty, you can then start scripting everything. We provide a bunch of high-level commands as well. I showed you a couple where I wrote a bit of Python, I printed a bunch of switch names from the database, which is dynamically updated. And then I ran one of my high-level commands, which basically just printed me a summary. Because it's there in Python, then there's a lot of interactivity we can build into that, make it intelligent, and look deep into problems that you may be seeing. One of the clever things we do, and we've got to finish with this because this is our finish actually, is we can find MAC addresses, for example. So if I know a MAC address, I have a little find function, find MAC, okay? And if I know the name of a MAC, and I've got one I stored earlier, and I can basically find that MAC address. I don't know anything about it, but where it is. Hopefully it's going to work. No. So it basically then interrogates the database, tells you the MAC address. It's on Plexxi switch P06. It's on port 21. Port 21 is up. And here's a list of the harvested information I know about that MAC address because I got this from VMware. So I know the host name, nickname, etc., etc. Now Derek arrived yesterday. I actually met Derek for the first time yesterday, right? And I showed him this because I was excited about it.
He did?
Yeah, this is a cool thing I created. He said, well, how about if you could search for all Cisco Macs or all VMware Macs? I thought, well, I don't know how to do that, he said. And Derek said, well, I do. And I sent him a bit of code, and he sent it back to me, and then I wrote, so do you want to come up, Derek? And sure. I suggest you do the VMware
The last
one.
thing we can do is we're
Yep. So if you do find tab, you'll see your command. Tab, yeah, find Mac Derek. Yeah, there he is. I even called it Derek. He's got to spell his own name right. And you've got to give it VMware. Yeah. So now it's going to look through the topology and look for all the MAC addresses that have got the VMware prefix in the MAC address. There's quite a few of them. That's the Plexxi switch. It's on again. This is the MAC address. It's web server 3 is a VMware.
So your CLI is Python. And if you don't like what's already there, just write your own CLI commands in Python.
In one place.
In one place.
Yep.
And what you do here has a network-wide view.
And the hook that you guys have with VMware, which is cool, which is kind of what Arista did with VM Tracer, taking the next level. When you have what Arista did and what you guys do, you don't need fabrics then. You don't need things like the UCS fabric. You can take much more generic things and start treating the network infrastructure as a fabric. That's what I did with my environment. And it's really powerful.
So we have time for just a quick closing statement?
Yes.
Okay. So thank you all, first of all. One of the things that, and this came up a little bit about automation. We're actually going to be opening up the Affinity language. It's actually completely generic of anything Plexxi. It just allows you to describe what your application components are and what they might need from the infrastructure. So we're actually going to make that available to the community. It'll be a GitHub site. We'll launch it in a week or two or something fairly soon. Our vision is kind of as we orchestrate applications in the future, I do vApps or I do OpenStack or something like that, we can start to build this knowledge, the Affinity knowledge, into the orchestration layer. And that's when we kind of get to the vision of everything's fully automated, because now I've encoded metadata at the orchestration layer that says what my affinities are. And then any types of physical infrastructure, ours is already built to kind of take advantage of that, but any type of physical infrastructure has essentially information, metadata about that application that it can use. So that is something you should look for from us. And that's it.
All right. Very good.